I recently purchased a Supernote Nomad to replace all my pen and paper. But upon checkout, one of the things that we need is a pen. And if you look at the website, pens range from $59 all the way to $89. But the thing that caught my eye is the Supernote Refill. Back in the analog days, my favorite go-to pen is the Pilot G2. And luckily, as per Supernote's guidance, this G2 pen is made out of all plastic, so it is compatible with the Supernote Refill. There are other models that exist on Thingiverse or printables for the Pilot G2, but this other model I found I didn't like because as per Supernote's guidance, the spring, or actually in particular, there shouldn't be any kind of metal objects near the coil of the refill, and the adapter that I found places the coil right at the refill, just like a regular pen. Now, I don't know if that causes interference, but in any case, to get the optimal performance out of this pen, I would rather move it away from the coils or relocate the spring away from the coils as per the guidance from Supernote. So that's what we'll be building today. This will be the final product. And in this video, I'm going to walk through the entire process from taking measurements to designing the adapters in Plasticity. The adapters are going to be very simple, but I think it's the thought process on what to measure, how I measured it, and how to get those dimensions into the CAD software that would be useful. So let's get started. We're going to take a look at the notes that I've taken. So first of all, a Pilot G2 refill, I measured it with calipers. I'm going to put the image up on the screen, but the entire length of it is about 110 millimeters. Now this is important because we want our Supernote refill to be basically match the length of this refill after we include all the necessary adapters. The next thing is the barrel of the pen. We need to know the length of the barrel of the pen because this is going to be where our first plastic piece is going to insert into the barrel. And basically this piece needs to go into the barrel, but also we will need to use the length to determine the size of the plastic that we insert into it, as well as where we need to put that stopper in order to stop the plastic from going further into the barrel. We need the inner diameter of the barrel because, of course, the plastic piece needs to fit inside it. And that I measured as 6.5 millimeters using calipers. And then we also need the outer diameter because that's where we're going to build that stopper that prevents the plastic from inserting further than it needs to. And the outer diameter is 8.05 millimeters. Now, the next thing, normally in a Pilot refill, you don't need to take into consideration the spring because the refill itself sits inside of the spring. But since we need to relocate the spring so that it's not sitting near the coils of the Supernote refill, the length of the spring will also be included in the calculation. So here I've determined that the length of the spring is about 19. And also I measured the diameter of the spring, which is about 5.5 millimeters, which I'll show why we need this diameter later on when we're in Plasticity. Now, as for the Supernote refill itself, the length I measured was 97.8 millimeters. The tip, including the flange. So here's a picture of the Supernote refill again. There's these flanges that stick out. This is where our first plastic piece is going to sit on top of. So we need to include, for the tip, we need to also include the flange so that we can calculate the remaining length of that plastic piece. So the tip, including the flange, is 16.5 millimeters. And then now the plastic needs to slide on top of the Supernote refill, so I need to get the largest diameter. So I measured a couple of places where I think might be the largest diameter, and the largest diameter I found is about 3.2 millimeters. So creating a hole about 3.2 millimeters will allow the plastic piece to slide on. And then, but at the very end, which is the tip, is about 3 millimeters. And this is important because this is where we're gonna have our second plastic piece. It's gonna sit on the tip, but it's also the piece that will engage the clicker of the pen. So we need to know the diameter for that. So now onto the fun stuff. Ignore this Pentel stuff because I did the same thing for a different pen. So ignore the Pentel notes. But for the calculations, basically for the first piece of plastic, we need, in order to know the length, I'm going to refer to this first piece as the base. The length is going to be our barrel length minus the Supernote tip because that's how long it needs to be. But it sits on top of the flange of the Supernote. So barrel length minus Supernote tip, which is 68. So again, if we go back up, 68 is the barrel length. So 68 minus 16.5, we know that the height of the length of our piece is going to be 51.5 millimeters. Now we're going to add a 5 millimeter stopper. This is just some arbitrary number, but it's just some plastic. As I said, is going to be the outer diameter of the barrel. So it sits on top of the barrel, but it's going to be about 5 millimeters in length. And then what remains so once we put, once we put the first piece of plastic on, put the spring on top of it, what remains of the Supernote refill is calculated as follows. Length of the refill minus the tip minus the length of the base minus the stopper minus the spring length. And then all of that will have basically a tail of about 5.8 millimeters left over, which is plenty, because for our second piece, the clicker, the side that interacts with the clicker, which I refer to as click here, 5 millimeters of that Supernote, the remainder will be used to attach that plastic onto the Supernote refill. And then, but the length that this plastic piece needs to be in order to engage with the clicker of the pen will just be the length of the refill minus the Supernote length, but we add 5 millimeters because we're taking the 5 millimeter tail and adding it to our plastic for a total of 17.2 millimeters. So that's basically all the measurements that I've taken. I've already put up images and I've referred to them. So now you know how it works. So now let's get started in plasticity. Now switching over to plasticity, we're already in millimeters by default. So the first thing I'm going to do is press A to select the cube that's in the new scene. I'm going to press X to delete it. And then the first thing is I'm going to switch to the top view. So from the top view, we're going to model that base piece first using the center circle tool from the origin. So we know that the largest diameter on the Supernote is about 3.2 millimeters. I want to allow for plenty of tolerance, making sure that the refill slides or the plastic slides on top of the refill without any resistance. So I'm going to add about a 0.4 millimeter tolerance. So here I'm just going to create this circle of 3.6 as the diameter. I'm going to press / to zoom in. And then now this piece needs to fit inside the barrel. So we know that the inner diameter of the barrel is 6.5 millimeters. I'm going to give it another like 0.2 millimeters of tolerance. I'm going to put in 6.3 and then press enter to confirm. And we said that this plastic piece, as per the calculation, needs to be of height 51.5. So I'm going to select this using face selection. I'm going to select this face over here, press D for distance, enter in 51.5. And that's that. So you imagine this thing slides into the barrel. But now we need that stopper. And the stopper is basically, it prevents the plastic from sliding in further than needed. And the stopper, the width or the diameter of the stopper is going to be the outer diameter of the barrel. Here we don't need to add any tolerance because we don't actually we want it to sit perfectly on top of the barrel. And then, of course, when you 3D print plastic, it'll have like slight shrinkage regardless of the material that you have, that you use. So I'm just going to enter the measurements directly. So 8.05 is what I got as the outer diameter. So that's what I'm going to enter. Now we still need to maintain this hole. So I'm going to use the edge selection. I'm going to select this inner circle over here. Press Shift D to duplicate that to make it a curve. And now I can extrude, going back to face selection, now I can extrude this face. And we said that this stopper is going to be 5 millimeters. So now I'm going to press A to select all, Q for Boolean, Q for union, right click to confirm, and now I have my first piece. I'll select all my curves and delete them, and I'm going to hide this first piece. Now I'm going to build the click side. So going back to the top view, I am going to use the center circle tool again. And here we said that the diameter of the click side on the Supernote is about 3 millimeters. I'm going to add about 3.2 millimeters, a 0.2 millimeter tolerance. Now, it's important here that this piece still needs to be small. This hole still needs to be small enough such that there's enough friction for this piece to grip onto the Supernote pen. This is how it when it makes contact with the spring. This is how it grips onto the refill and pulls it back out, right? So this hole still needs to be small enough that it can grip onto the refill, but large enough so that you can actually fit it onto the refill. So 3.2 is what I found that works for me. But if your printer is super good, it's super well tuned, maybe 3.1, maybe 3.15, find the value that works for you. 3.2 is what worked for me, so I'm going to put 3.2. And then for the outer circle, I'm going to use the same thing. It's going to fit inside that barrel, so it's going to be 6.5. 6.5. I'm going to add some tolerances of 0.2, so 6.3 millimeters. And now, first thing is I'm going to select both of these faces. I'm going to extrude it to the right length. So here we determined that the length of this clicker piece needs to be 17.2 millimeters. And we set that 5 millimeters of it will sit on the end of that Supernote refill. So I'm going to rotate to the bottom here, select this face over here, press D for distance, enter in 5, press W for difference, click on this body and to make that cut. And now that's it. So this is basically the all you really need for the most basic adapter. If you print these two pieces, your pen should work fine. Of course, it's very simple, right? A couple of cylinders and that's it. But so that's not super interesting. But since we are 3D printing this, there are some other stuff that I considered. So I'm gonna go into if this is all you want, a simple print that just kind of just works. Then this is all you really need. Export these two pieces and you're done. Now, the addition that I wanted to do is that if you imagine, we need to also insert the spring in between the middle of these two pieces. If I go back to the first piece, now go back to the top over here. Now the spring is going to sit on top of this piece. But what ends up happening is when you click and unclick, that spring might wobble back and forth. So like the spring is on top of this piece. But as it's kind of contracting and expanding, it might wobble to the left and to the right. And there's a lot of play in where that spring sits on top of this piece over here. So in order to minimize that play, what I did was I measured out the diameter of the spring, and this is where I'm going to use it now. So basically in addition to this piece over here, what I'm going to do is now I'm also extrude a wall that kind of contains that horizontal movement of that spring. So that's what we're going to do here. So using the center circle tool again, I'm going to click right on the center. And that spring had a 5.5 millimeter diameter. I'm going to give it a tolerance again, 0.2. So I'm going to do 5.7. And then also we need to reference this outer circle over here. So I'm going to use the edge selection, select this edge, press Shift D to duplicate. Oops. Edge selection, select this edge, Shift D to duplicate. And now I'm going to extrude a wall. And here another 5 millimeters worked for me. So I'm going to press D for distance, enter in 5. Enter twice to confirm, select everything, Q for Boolean, Q for union, right click to confirm. So now that spring, we've restrained the kind of movement to to within this wall. So the spring doesn't move around as much when we put it on top of here. So similarly, I'm gonna do the same thing for this other piece. So I'm gonna rotate all the way to the bottom over here and zoom in. And we said the spring was 5.5. So again, I'm going to add 5.7, 5.7, come on, 5.7. And then also take this edge, Shift D to duplicate, select this face, D for distance, enter in 5 again, make sure it's in the right direction, enter twice to confirm, A, Q, Q, right click, and that's it. So now the last consideration is that I'm going to be 3D printing this. So 3D printing, this piece over here, that's fine, right? So if we had it in this orientation, let's say this sits on top of the build plate, this prints perfectly. Now, but if we look at this other piece though, so if we printed it from this orientation, which is how we designed it initially, we have this overhang over here. That's not what we want. So what if we flip it? So we rotate it by 180, right? What if we flipped it? So we flipped it now. Will this work? Well, sort of works, but because I added this piece over here to hold the spring, now we have an overhang over here. Now, for a small print like this, overhangs might be fine, but there is a trick, and I'll link to the YouTube video that basically some modeling techniques that tricks the slicer into doing some bridges before printing this hole. That makes it so you don't actually need supports. But if you're okay with supports, you can print in this orientation, add supports for this ring, and that's fine. But here I'm just going to do that extra little consideration so you can print without supports. But I'll link to the YouTube video that shows you this technique in depth. But for the sake of this video, I'm just gonna do it. Okay, so what we need to do is basically the first thing we need to do is referencing this inner circle over here. I'm going to create a rectangle of the same length. So I'm using the center rectangle tool, making sure I get the correct center. So let's see over here. I'm going to press C to make it into a center rectangle. And we said that this hole is 3.6. So I'm going to enter 3.6 for the width, 3.6 for the height. And then I'm also going to make another rectangle, center rectangle. And for the height, I'm doing the same thing, 3.6. But for the width, it just needs to be beyond the part. And then lastly, I need this inner circle as a reference. So I'm going to using the edge selection, I'm going to select this inner circle, Shift D to duplicate. Now everything I need. Now, basically what we're going to do is we're going to extrude cut about 1 layer height's worth of these two parts, of these two selection, of these two faces, and then extrude cut this square over here of 2 layer heights. And what ends up happening is that this top and bottom part becomes one bridge, this left and right part becomes another bridge, before we then print the circle on top of it. And that allows it to print without supports. So, but one thing that's weird I found in Plasticity is that if I try to, so let's just say this one's going to be the first bridge. So I'm going to select the left and right to be the first cut. That's going to be, so I'm going to select these two faces, press D for distance, enter in 0.2, press W for difference, select the piece. For some reason, Plasticity says the Boolean failed, and I don't really know why it does that. So the only way for me to fix it is to actually create this hole at as the last operation. So I'm actually going to just select this face and press to enter into offset face, press D, and then I'm just going to drag it until that hole disappears. Now I'm going to re-enable those curves and I'm going to redo the operation. And now this time it should work. What did I do? There we go. Okay, so yeah. So I'm going to select these two faces, press D, enter in 0.2, press W for difference, select the model, right click, and now it works. So if I hide these curves, you can see that makes that first cut. So secondly, I'm going to select this square in the middle, press D, enter in 0.4 now. So this is for the second layer, right? So this is assuming your layer height is 0.2 for 3D printing. Press W for difference, click on the model, right click to confirm. So now if I delete all the curves, you can see like if you imagine it slicing, this will be these two pieces will be the first bridge, these two pieces will be the second bridge, and then it prints the whole, right? So now the whole has some contact to sit on top of, and there's no need for supports. All right, so we need to add back that hole now. So I'm gonna add in 3.6 with this curve selected, C to enter the cut, select the model, right click to confirm. It selects that cylinder, that's the result of the cut, press X to delete. Now that's our model. And that's pretty much it. Those are the considerations I did to make this adapter. This is the end result. I now have a pen that costs what, like $2 for a 2-pack, plus the refill for $34. So let's just say $36 for the pen, not including tax, versus the minimum that you would have on the Supernote website is $59, I believe. So let me see, yeah, $59. So that's that. Hopefully this helped anyone who's in this category making custom pens. You can follow the video. You can apply similar techniques and customize your own pen. Thanks so much. Have a good one.